find it this way.
Emulate.
Well, I have an emulator on my PC, but
No. I mean, make your own hardware. Take a serial ATA hard drive, make your own hardware, so you can still interface with the Commodore. You can probably do it. You can probably figure out like data communication.
I was actually thinking of stripping everything out of the Commodore itself and building a PC inside the Commodore and keeping it.
You can probably do it because hardware these days can emulate any old hardware that you have before. Once you know the protocol and how to talk in electronics, the rest should be fairly easy.
I'll put some flash RAM in the fast load cartridge.
Alrighty, let's go ahead and get started. Are there any questions about the second subroutine homework assignment, sub 2?
Yeah.
Questions? Okay. So let's go ahead and take a quick look at it. And I'm gonna create a folder for today's class.
It is not due today, right?
It's not due today, but I do want to ask questions and see whether people have any questions.
Did you start the recorder?
Yes. I have to shut down. All right. Come on, people. Let's settle down. Okay, a few people said there were questions about sub 2, so let's get started with sub 2 here.
Are you gonna go doing the homework right now?
No, I'm just going to talk about it. I'm not going to do it. All right, so this is the homework assignment, and your question is?
On line 19, we have the invoke, assign, and then invoke add. I didn't know how exactly do we write that in a trace.
Okay. So we have an invoke within an invoke.
Yes.
So the question is, how do we trace it? You can only make, in this particular case, you can only make one invocation at a time. So the question is, should you invoke add first or should you invoke assign first? Which one can be done first? You can only do one at a time.
Yeah, the add.
You have to do the add first. Okay, so the first thing you have to do is to invoke the add. Does add return anything?
Yeah.
Okay, if add returns something, that means when you get back onto line 19, you still have something else to do. So you need to use return info for the first invoke. Does assign return anything? Assign does not return anything. So that means when you invoke assign, you can choose, you can use return info because you can always just say, okay, I'm going to return to line 20, or I can just say return line number as 20.
Okay, so we would first do the invoke add, and then we go all the way back out to line. So when we go
19.
So we'd go to line 9 after we invoke line 19 stuff. We go to line 9, and then go back to line 19.
Well, this is a nested invoke. So let's see whether we have anything like that from last class meeting. And that would be one level up. Do you remember this program?
Yeah.
So this one also has a nested invoke.
I thought that's how we were supposed to do it, but so we do the invoke add, then we go all the way back out.
Okay, guys. Okay, can you guys kind of like? Okay, go ahead.
So we do the invoke add first, and then we go back out, and then redo
The multiplication.
Okay.
Right. So you have to do something similar in this case, except the parameters are different because we have passing by reference instead of just passing by value. But in terms of the order of the invoke, it is the same thing.
So my other part of the question is, so would we write out a separate invoke? So we go invoke invoke assign, and then set up the X and Y, and then do another invoke of
It will
add,
be-
or is it just like one line?
It should be similar to this one
Okay.
in many ways.
That's,
You can see how many times we have to go back to line 11. Line 11 has one invoke, and then we get back to it to have some additional stuff to do
Okay.
on line 11.
Can you upload that?
now I'm there.
Sorry?
Can you upload that one?
Yes, I can. So let me close it first. And, okay, let me just upload the file first before I forget. And that's from last Thursday. This is free archive. I cannot use the GUI, sorry. I can do this a little bit easier, quicker. That's 08. Go back to Google. Is that gonna be okay? I mean, do you
Yeah.
get enough
I get it.
information? Okay.
Yeah.
What about the other people who raised their hand about the new homework assignment?
Same question.
Sorry?
Same question.
Same question? Did I just address that?
I think so.
Okay. So let me just upload that file.
Pretty sure you did it right.
In topic 9 already. Add a new file. The screen is too big, I can't see it. That's that's 08. Where is it? Alright, so that should be uploaded. Save and return. Now we're done. I can give you guys some more examples too today. Are there any other questions, in general about the concepts of returning a value or passing by reference, passing by value? Any specific questions? No specific questions? Yep, go ahead.
I can't quite remember when it says for the homework 2, it says invoke main. When you go to main, you're supposed to do the return line and its post. Then when it's on line 18, it says local I. And then on line 19, it says I gets value 2. Do I do all of that when I invoke the main, or do I
Okay, let
say
me-
return line? Then I have line 18, then you see I show up, and I have line 19, then I gets a value. Do I do it line by line like that, or do I just
Okay.
kind of do it all at once?
Okay, can you ask that question again?
Line 22.
Okay.
Invoke main.
Right.
I know you have to do the return line, and since it's the last one, it'd be post.
Mm-hmm.
Do I define local variable I at this time, or do I wait until once I'm in the subroutine?
For this class, you can allocate the storage when you allocate for the return line number column.
And when do I invoke that I gets a value of 2? Do I wait until I get to line 18?
Yes. You
So
have to wait until line 18.
Until then, it's just blank, not question mark?
It is a question mark.
Question mark.
It's a question mark, because if it is a local variable, it has a value already. You just don't know what value it is. That's the standard of C. When you write C programs, like this, the equivalent program written in C will have the concept of local variables as well. So local variables always have a column allocated to it, but you don't know what is the gibberish in that column already, and that's why it starts with an unknown value. And that's why when you create a column, when you allocate a column for a local variable, it always starts with a question mark to represent it has a value, but you don't know what it is.
But I can allocate local variable I at the same time I do the return mode.
That is correct. That's the way we do it in this class. Yep. When you get to cisp300, the assembly programming class, then it's not going to be in the same. It's not going to be at the same time anymore. But this is not cisp300, so we'll just allocate all the columns for a particular invocation at the same time.
Okay.
Yeah. Yep.
I have one more quick question.
Go ahead.
When we go back to the do the assign, do we put all between I and Y into the question mark for that second part of the invoke, or?
Well, the way you invoke is whatever subroutine you're invoking, whichever one you're taking care of, is the one that get replaced by a question mark.
Okay, so let's say I've already done the invoke add, I've come back to do the invoke assign part.
Right.
So I put the I and X and Y part into the question mark, right? From the I all the way to the Y, I replaced that all with a question mark in the parentheses, correct?
When you invoke it again?
Yeah.
When you invoke assign, you have the option to. No, that's not true, because assign as a subroutine does not return a value.
Okay.
So you don't need to use return info. If you do use return info, you're not going back to the same line.
Okay.
Because when assign is done, you
Okay.
move on to the next line.
Okay.
So your return info, if you choose to use return info, should be line 20 with the entire thing on line 20.
So the first time I should use the return info because we're doing the invoke add, but the second time I could just use return line number.
Correct.
Okay.
When you're invoking a subroutine that does not return a value, it is more convenient to use return line number. Because if you choose to use return info, it will just be the next line and its entire thing, the entire line of the next line.
Okay.
Any other questions? No other questions about subroutines? All right. If there are no questions about subroutines, what I'll do is I will move on to the next topic. If you guys can think of any other questions about subroutines, let me know, so I can cover that material in the class. If not, we can go over some of the exam 2 questions. Do you guys want to go over some exam 2 questions? I think that's probably a good idea as a practice. It's probably good. Okay, let's go through some of the exam 2 questions. All right, so this one is also designed for the previous class, where we have not multiple choice questions. These are all open-ended questions. So we'll go ahead and open up one.
So there won't be no multiple choice questions on the exam?
Sorry?
There won't be no multiple choice questions on the exam?
With our exam, it will all be multiple choice. Yep. Okay, that's not. Let's pick another one. That's not subroutine. Those are all, just arrays. That's a binary search. Where are the subroutines? Okay, that may be the wrong one. That's the actual exam 2 from last year. So this one is actually from last year. And it has only arrays in it.
How much questions are going to be on the test? How much questions are going to be on the test?
I have not decided yet.
Approximately.
Approximately.
One.
You don't want to have one. Trust me, you do not have only one. You want to have a little bit more. So if you did not answer one correctly.
But if the name is one,
Yeah.
There you go. No, that's the one.
You have no subroutines here. Okay.
Oh, wait.
So with our exam, it's going to include subroutines. Okay, so we will have subroutines in our test. All right. Any questions about that?
Question about the.
Yes.
So for the practice exam, I noticed there's no answer, no keys for the.
No keys. Well, that's because it doesn't include subroutines in these practice exams. So yours will have, on Thursday, on this Thursday, I'll give you a practice exam for this class. So it will have, subroutines and also, things that are basically everything that we talked about after the previous exam and up to subroutines. Okay? So one thing I do want to illustrate is how do you integrate the concepts of arrays and subroutines? Okay? Because we have talked about arrays separately. We have talked about subroutines separately. So how do you get those two to work together? Well, first of all, do we want to have those things to work together? Does it make any sense to make those things work together? Okay. So let's go ahead and take a look at some of the problems that we have already talked about, or some of the algorithms that we have talked about already. I'm going to write this in a way, I'm going to go back and change a lot. So don't copy everything because you'll have to make a lot of changes. So first of all, I want to write this particular algorithm. Yep, go ahead.
Video on?
The video should be on, and it is. Yep, looks like it's recording my
Check the
voice.
terminal, make sure you have space.
It's recording radiation from outer space. You open it up, it's like, aliens talking to you. All right, so let me go ahead and write this algorithm, and you guys can tell me what it does, okay? Because I want to see if you guys still remember this. It has arrays. And I should write a little bit more, but if I just leave it like this, well, first of all, at line 5, okay, let's say there's something on line 5. When I'm on line 5, what has to be true on line 5? So we're kind of going back to, and analyzing the code, and figure out what is the post condition of a loop here. And I promise you guys that I won't use your pre and post conditions anymore. So I'm not going to use those terms, but I just want to ask you, what is guaranteed to be true on line 5? Yes? That is exactly right. Okay. On line 5, the only one thing that we know for sure is I is less than bar a bar and k does not equal to a bracket I has to be false. Is that right? Okay. So I'm going back to. So I'm trying to integrate a few things. In this case, I'm trying to integrate not only the algorithms, this particular algorithm, but also how do you read an algorithm and try to understand what it does. Because when you become a software engineer or a programmer or developer, sometimes you encounter code that has no comments. In other words, there's nothing left behind from the previous person who wrote the program that explains what it does. So what do? Well, send the guy an email. That person may not be reachable anymore. Some of the COBOL programmers are dead. You cannot ask those people, hey, can you explain this subroutine or this line of code? No, those guys are gone, as in gone.
That's when you invoke the spirits of the Ouija board.
The digital version as an app. I'm pretty sure someone has written an app like that already. All right, so what we want to do is to say, after line 4, what is guaranteed? Now, if you just look at the code here, the only thing that's guaranteed is the condition of line 2 has to be false. That's the only way you can get out of the loop. And this is also a good reason why people should not use gotos or breaks. Okay? Those are two constructs in almost every programming language that allows you to go from inside a loop to get out of the loop. But it does not require, it's basically just a statement between line 2 and line 4 that says, oh, it's time to get out of the loop. But if you use constructs like that, then you can no longer use the analysis technique that I'm using here, because I'm only using the condition of the loop to analyze the code to figure out what is the post condition of the loop. But any type of break statement or any type of go-to statement will make that type of analysis impossible. And people would say, but this is a simple program. Surely if I use a go-to here, it is obvious, why we are getting out of the loop. It may be obvious when you have a short program, but if you add more code to the program, sooner or later, it becomes difficult to track down the logic. What does it mean when I'm out of the loop? Well, it may be this reason, maybe that reason. You can no longer just look at the condition itself, which in this case is line 2, to decide why you're out of the loop. In this case, the first thing is I would say it is not the case that I is less than bar A bar and K is different from A bracket K. That is guaranteed to be true. The negation of the condition on line 2 is guaranteed to be true. But that can be a little bit difficult to read. So what I would do is to use De Morgan's law. Use De Morgan's law to make this easier to read. De Morgan's law says you can apply the negation to each individual item, but then you have to change the operator to a disjunction. So in this case, it means we have the negation of I is less than bar A bar, and then change the operator itself to an OR, but then you also have to negate the other side. Okay. Well, I can simplify this even more because it is not the case that I is less than bar A bar means I is greater than or equal to bar A bar, or it is not the case that K equal. I applied one simplification too early. Now I can apply the simplification. Now it's easier to read because I is supposed to be the indexing operator, the indexing variable into array A. How do I know that? How do I know that I is the indexing variable to look into array A? What gives that away?
I in the brackets.
I inside the brackets, exactly. The square brackets are called the indexing operator. And you can see on line 2, I'll just point out where. On line 2, you can see that I is appearing inside the square brackets. So that means it's used as an indexing variable. So in this case, the first condition is saying that, I is no longer a valid index into array A. And that means I could not find any item in the array A that matches the value K. The second condition is saying K equals to A bracket I, which means there's one specific item in array A that has the value of K. So I'm using either way to get out of the loop, and as he said, I'm getting out of the loop after I can either confirm that no item in the array has a value K, or at least one item in the array has the value K. So what is this algorithm doing? Well, it confirms one thing, right? It confirms one of two things. It is a search algorithm. It's a linear search algorithm, which means it will work in arrays that are either sorted or not. Okay? It just linearly scans through the entire array, look for a particular value. If that value cannot be found, then it exits also. Is that making any sense? Do you think this might be something that you want to do in a program from time to time? Linear search is useful, okay? All right. So instead of using this code and copying and pasting it multiple times throughout your program, maybe it makes sense to turn it into a subroutine, right? Because once you turn it into a subroutine, you can invoke it from different places of your program and change the parameters to make it do different things, or work on different arrays, look for different values. All right, so let's go through the exercise of turning this into a subroutine. How do we do that? I know how to do it. It's easy. Insert a row, say define sub linear search, and define sub, and do the indentation thing. We're done. Right? What is the problem with this approach? I mean, it's easy to turn something into a subroutine. Just extract it out of the main program, put in define sub, and define sub, we're done. Exactly. So in this particular subroutine, it is a subroutine, okay? It has, you can invoke it, it will return. But it has one problem. I is not a local variable, which means it's a global variable. A the same way, and K is the same way. So we have 3 global variables in this case. And what do I say about global variables? They're evil. Evil. Okay? So we don't want to do that. Okay? We don't want to use global variables whatsoever. So the next question is, okay, if the 3 names that we need here are not global variables, what should they be? That's the question. Well, let's analyze how these variables are used, and then we can determine, what they should be. So I'm going to insert 3 more rows here. And this is why I said don't copy it, because I'm going to make changes along the way. Let's deal with I first. I is the easy one. Okay? Is I serving any purpose to the invoker, whatever code that is calling the subroutine? Does I offer any value? Not really. Sorry? It just counts it along. Does it provide any value to whatever is calling the subroutine? What do you think, why would I call a subroutine called linear search? Is to confirm whether an item is, or a value is in the array or not, right? Does that make sense? Okay. Now I can be used to indicate that, but it's better to use a return value instead. So I'm going to do that also here, is to go here, insert a row, and say, I think we have to return some kind of an answer. But instead of using answer as answer, I'm just going to make it italic, which means I'm going to fill in details later. Okay, this is not what I really want to return, but I know I'm supposed to return some kind of value later on. Okay, so getting back to I, it doesn't serve any purpose to the invoking code. What about the initial value of I? Do you think the invoke statement should specify the initial value of I, or do you think the subroutine itself should set the initial value of I? This is fairly obvious. The subroutine should initialize it. Because you can see that I, on line or row 5 here, I gets 0 is in the subroutine. So that means, even if the invoke statement is giving it any initial value, it gets overwritten right away by the subroutine itself. So that means it should be a what? It should be a local variable, because it gets overwritten by the subroutine right away, and it does not provide any value to the invoking statement. So I'm going to put it here and say local I. I is a local variable. What about K? K is the next one. What should I make K? Should K be a local variable? What happens when K is a local variable? What is one property of a local variable? What is its initial value? It does disappear. What is the initial value of a local variable? It is unknown. It's not nothing. There's a difference between nothing and unknown.
You could have reason on it.
If it is unknown, it can be nothing, but if it's nothing, it is not unknown. Does that make sense? Okay. Okay, so K is unknown if it is a local variable. Do I want to compare A bracket I with some unknown value and get out of the loop because of that, because it matches or not? It's a linear search algorithm. Do I want to search for some random value? No. So who should specify the value that I'm searching for? The subroutine itself or the invoke statement? The invoke statement. Very good. Okay. So if the invoke statement is responsible to specify what I'm looking for, I know it has to be a parameter. Am I changing K? If you look at how K is used from row 5 to row 8 in this program, am I changing K? Does it appear on the left-hand side of an assignment? No, does not. So that means the invoke statement is specifying the initial value, but in the subroutine, I never change it. Do you think it makes sense to make it a pass by value, pass by reference parameter?
No.
It doesn't have to pass. It does not need to be passed by reference. It can be passed by value, because the subroutine is not even changing it. In other words, the invoke statement knows what it is, and it's not going to change. So that means I want K to be passed by value. Okay, so if you apply the same argument, then you can say that we can do the same thing with array A. Array A can also be passed by value.
Yes, but with the K, would there be a reason you would need to know
Whether there's a match or not?
Yeah, so
But
why
you're not
would
going
you
to use it, well, we'll use the return statement for that purpose. Okay? What about array A? Now, this is the really tricky part, because if you use the same analysis and say that, well, array A cannot be local because we are using it for comparison, so it cannot be, the elements should not be unknown. And at the same time, I don't have A bracket something on the left-hand side of an assignment. I'm not changing anything in the array. And based on those two observations, we think that array A can be passed by value as well. Well, it can be. Okay, so we'll go ahead and see what happens when we do it this way. I know some people who know C programming already turning their head because it is not possible in C. But in other programming languages, such as Visual Basic, you can. Okay, so we'll see what is a potential problem with this approach. So in here, we have a main subroutine here. And then we have to say local A, and in this case, I'll just be more specific here. A is an array of 3 integers. Okay, I'm just being more specific, so when we create it, we can kind of look into how this is going to be created. And then we can go ahead, oh, there's one more thing we need to work out. What about this return answer thing? In other words, to the invoke statement, what is important to the invoke statement? What is the invoke statement trying to find out? Whether the array has a value k or not, right? Is that a number that is returning?
No.
It's a Boolean. Okay, it's a Boolean. Okay. So that means whatever we are returning has to be a Boolean expression. This answer part has to be a Boolean expression. What should it be?
Find A.
Hmm?
True or false?
Well, let's take a look at several options here. Okay. Can we do something like that? A bracket I equals k. Doesn't that confirm whether we found it or not? Except there's one problem here. If k does not exist in the array, what would I become? Okay, let me say that again. If the array does not have a value k, what do you think will get? What do you think is the reason that I'm getting out of this loop? The array does not have the value I'm looking for. So it will be exiting the array, exiting the loop because I is greater than or equal to bar A bar. When I is greater than or equal to bar A bar, is it still a valid index into the array?
No.
It's not. So that means if I use A bracket I equals to k as a return value, it can return the wrong information in the C program. Okay? It may not crash because it's accessing the location of another variable or something else that the program needs, which may turn out to have the value k. Okay? So it can still it can return the wrong answer. It can return what we call a false positive in this case. So this is not something that we want to use. So if I cannot use the comparison between an element and the value k, I think our only chance is to somehow compare I to bar A bar. The question now is, what should be the comparison operator in between them? What do you guys think? If a value k does exist in array A, what is guaranteed? What is the guaranteed condition or relationship between I and bar A bar? Less than, just less than. There's no equal to, only less than. Is that making any sense? It does not equal to because if k does equal to bar A, if k equals to A bracket I, this condition has to be true, right? So that means I is less than bar A bar means that we found the item in the loop. Is that working or not? Kind of? Okay. But that's basically what I wanted to show you is how do you analyze an algorithm and figure out from the result of the algorithm how can we extract the actual answer in this case? All right. So I'm just going to put some gibberish here and say, put some values into array A. And then I can go ahead and invoke the subroutine. So I'm going to say print invoke linear search. I will use my own array A, which is a local variable, to specify A as a parameter passed by reference. And I'll just say, I'm looking for a constant, in this case. Let's say we're looking for 6. So I'll put it into parameter K. And this is the end of subroutine main. And then from the outside, I just want to invoke main. That's my whole program. And tracing this program is going to be interesting because we are going to show. I'm going to show you guys, what does it look like when we have a local variable that is not a single item but an array, and how do we pass it by value, which is only possible in certain programming languages. So those are the two particular questions that I'm going to answer with this sample program. We'll save it into today's folder and say linear search passing by value. So open up new window, change the size. So, okay. All right, so we need one column for comments because we have print and conditional statements to evaluate. We have line number. And the precondition has nothing to say because we do not have any global variables. We start execution on line 16. Line 16 is going to invoke main, which means we need a return line number because main is not returning a value, so we have to specify we just return to post. And then we have to specify the local variable in this case. A is a local variable, but A is an array. There are 3 elements in A because I say that A is a local variable, is an array of 3 integers. So that means A as a local variable is going to take up how many columns? Exactly 3 columns. So that means A bracket 0 will take up column E, A bracket 1 will take up column E, and then A bracket 2 will take up column F. Are there any questions at this point? Well, is that a new concept, or do you think it's an extension to something that we already know? It's just an extension. Okay, it's not a real new concept. We already know whenever we deal with arrays, the number of elements determine how many columns we need to allocate. We also know that local variables need to be allocated on the fly when you invoke the subroutine, and that's what we are doing here. All right. So now we can go ahead and move on into the subroutine, starting on line 13. Line 13 is a mysterious statement. Put some values into array A. So for whatever reason, oh wait, I cannot start yet, because these elements will start with unknown values to begin with. So I do have to indicate they start with unknown values, just like with any local variables. So if you have a local variable that is an array, each element starts with some unknown value. Then we can move into the subroutine starting on line 13. Line 13 will put some values into these things. So we'll just put in like 5, 4, and 7. So 6 is not there. And then we move on to line 14. Line 14 is a print, but we cannot do the print part until we know what value we are supposed to print. Yep, go ahead.
Yeah.
Oh. Wrong column. Oh, you're right. Here we go. So now we are executing line, the other one, that one too. Go. On line 14, we are going to, yep.
How do we know how many elements is an array? Was it given?
An array of 3 integers.
Okay. Thank you.
Mm-hmm. In C programming, that has to be a known value. You cannot say, an array of, whatever number of, integers. So whenever you create an array, you have to tell the program how many items do you need in the array. And that number cannot change. On line 14, we have an invoke first. So we have to invoke linear search first, and then whatever it is returning, either true or false, we'll print it out. So that means we need to use a return line number or return info in this case. And do I have to go back to line 14 after the invoke?
Yes.
Yep. If that is the answer, we need a return info. So the return info is going to say we have to get back onto line 14. And when we do get back onto line 14, we have the print to take care of. But whatever we are printing is going to be the return value of linear search. Is that making any sense? Okay. So that's one thing we have to set up. Now, linear search has two arrays, and I made a mistake here. It should be a single-sided arrow, not a double-sided. I kind of time traveled and looked into the next program already. All right. So it has two parameters. A is an array passed by value, and K is just passed by value, a simple value. So what should we do with A in this case? A is passed by value, which means we have to allocate 3 columns for this new array. Okay. So this is array A as a parameter. It has 3 columns. But because it is a part of the invocation, this array A, which is columns D, E, and F, will be used to populate the new array, which is columns H, I, and J. So it is just a copy of the other array. But it does take up 3 additional columns. And then we have K, which is just a normal pass by value parameter. And 6 is used to specify K, so that is just a value 6 here. And now we can continue our execution inside the binary search, the linear search subroutine. Are there any questions at this point? No questions? Did we encounter a brand new concept, or did we just encounter a new application of what we know already? It's an application of what we know already, because we know passing by value means whatever you use to specify the parameter, you just make a copy of that available only to the subroutine that you're invoking. And that's exactly what we are doing here. All right, so now it's time to continue execution inside the subroutine, which is going to be the most boring part of this. Oh, I forgot one thing. What did I forget? I, yep. I is a local variable, so what should I put in column L? Question mark. Exactly, because its initial value is unknown. And now we are running out of columns. I can make this a little bit bigger. There we go. On line 5, I want to initialize I to 0, so I gets a value of 0. On line 6, we have to evaluate the condition. I is less than bar A bar. Is that true? I is 0. What is bar A bar?
3.
Bar A bar is 3. 0 is less than 3 is true. Okay. And this is a conjunction, which means I have a second chance to make the conjunction false. The second part is asking, is K different from A bracket I? K has a value of 6. A bracket I is A bracket 0 because I has a value of 0. A bracket 0 has a value of 5. 6 is different from 5 is true. So we have true and true, which is true. So if I want to make this one as wide as possible, I will have to split the screen like this. So this way we can see all the parameters and also the local variable. We go to line 7. Line 7 is going to add 1 to I. I goes from 0 to 1. We go back to line 6. What do you think is the condition? It's still true because I has a value of 1. 1 is less than bar A bar, which is 3, is true. K is 6. I never change K. I is 1, A bracket I refers to A bracket 1. A bracket 1 has a value of 4. 6 is different from 4 is true. So we have true and true again. Then we go back to line 7. We add 1 to I. I goes from 1 to 2. We go back to line 6. And it's going to be the same condition. It's still true. Then we go to line 7 again. I goes from 2 to 3. We go back to line 6. And because we have short-circuited evaluation, then we say I, which has a value of 3, is less than bar A bar, which is also 3, is false. And we do not need to read the entire thing, because if the first condition of a conjunction is false, the entire conjunction is going to be false. And this is, I really need to emphasize this because it is short-circuited evaluation, which is in C and C++ and most programming languages. Are we doing okay so far up to this point? Okay, nothing too exciting. Then we move on to from line 6, we move on to line 9. Line 9 is returning I is less than bar A bar. Can I do that? It's not a number. It's a Boolean. What is the value of I at this point? 3. What is the value of bar A bar? It's also 3. 3 is less than 3 is false, okay? And we are returning the value of false. How do we return a value? You use the rightmost return info column. You copy and paste it, and then you change the question mark to whatever value that you're returning. In this case, what are we returning? False. Not 3, we're returning false. We are returning the result of the comparison. We are not returning I. So after line 9, we go to line 10. Line 10 is the end of the subroutine. It has 2 things to do. One is to look up return info and say what else do we need to do on line 14. I'm changing my way of tracking here and just copy the entire line over here. And then what do we need to do? We can deallocate all the columns that we allocated earlier for the invocation. So we just copy and paste all the heading and then indicate that these are all deallocated now. And now we're back to line 14. But line 14 does not look like print in parentheses invoke blah blah blah. It is simply printing the value false, which we can do right now. So in here we'll say I'm printing a value of false, and then there's nothing else to do on line 14. We move on to line 15. Line 15 is over here. It is the end of a subroutine. 2 things to do. Look up the rightmost return line number or return info. In this case, it's a return line number telling us to go to post. And also, we have to remember to deallocate all the columns. And this one is a little bit tricky because it doesn't really show that A is crossing 3 different cells. So if I want to be picky, I'm going to merge these 3 cells into one to indicate that we are dealing with 3. I just did something I'm not supposed to. There we go. And that's the entire trace. Are we doing okay so far with this program, with this trace?
I still have a hard understanding of line 9.
Line 9 in the program.
Yes. In the
Okay,
program.
well, let's take a look at line 9 in the pseudocode. You're talking about this statement.
Yes.
Okay. Let's not think about the rest and just look at the highlighted portion. What is that? Just the highlighted portion of line 9. What is that? It's an expression. Okay, it's an expression, and it's basically what kind of value does it return? True or false? Okay.
Okay.
Okay, so I'm taking whatever it is evaluating to and use it as my return value.
So if that were to be true, when we get to that point, we would put print and then true in the.
Mm-hmm.
Okay.
whatever I is less than bar A bar is, which is either true or false, that becomes the return value.
And
So the
that's what
question
we
mark,
print on 14, okay.
right, so the return info cell will have the question mark replaced by either T or F in this case. Okay, so that's the trace of this program. But when you look at the trace like this, what is the problem of this approach? Well, let me ask you another question. Columns H, I, and J, do they really need to be there? No. Because I can just say, okay, look back into columns D, E, and F and search in that array instead of creating a new array. And that's the problem of passing arrays by value. Because when you pass by value a single integer, it's no big deal because it is just a single column. But when you pass an entire array by value, if you have an array of 10,000 items, the parameter passed by value will be the same size as the original item. And that can be very wasteful. All right? And that's why passing by value, using an array and pass it by value is impossible in C and C++. Is that okay? You have to remember that, okay? It is not possible to pass an array by value in C and C++.
Because it's a waste of time.
Well, because it's just inefficient.
Yeah.
If you do require to pass an array by value because you may be making changes to it and you don't want the owner of the original array to see the changes, the subroutine will be responsible to make a copy inside the subroutine itself. Okay? All right, so if this is not possible, what about the alternative? I'm saving the file right now and we can save it again using a different name. It's being very slow. At least it's still recording. I'm going to save the program again. This time I'm passing it by reference. Now if I pass it by reference, I should probably delete a whole bunch of stuff here. So I'm going to delete everything from here to here. And we'll split the cells. Go back to the algorithm. And then change just this thing here. Instead of passing by value, I'm now changing it to passing by reference. Okay. So let's go ahead and trace the algorithm again and see what it looks like when we change only that portion to passing by reference. Yep.
Can't K be by value?
K?
Yeah.
K can be passed by value or by reference, but if it's passed by reference, I can no longer use 6 or a constant to specify its value. And we are not changing it either. That's an interesting question. Can we or should we pass K also by reference? That's the question. As it turns out, a reference takes up one column. An integer also takes up one column. So you're not gaining anything by passing by reference in that case. Is that making any sense? Okay. Plus, we are not changing K, so it doesn't really matter whether it's passed by reference or passed by value.
Would there be a particular reason, like if you're writing a full-scale program, where having K be by value or by reference would make a difference? Would there be a
Only
reason?
if K is not a simple thing, then you might want to consider passing it by reference. In other words, if you have I'm jumping ahead of myself a little bit here. If you have an array of, let's say, dates, okay, as in year, month, and day. If you have an array of dates, then the key itself is not going to be an integer anymore. It is also year, month, and day. So in that case, if you consider year, month, and day, it takes up 3 columns. So passing the key by reference can still be saving you 2 columns. It's not worth it But in some cases, yes, you can pass the key by reference if you want to. Okay. So let's go back to this algorithm and continue tracking it down on line 14. So now we are on to line 14. Line 14 says, print invoke linear search, and this time I do have to change the arrow back to double-sided, because I use double-sided arrow whenever I'm passing by reference, and only use a right arrow when I'm passing by value. When you write C programs, it doesn't do any arrows or anything like that. You can make all sorts of mistakes in the actual C program. But since I'm dealing with this in pseudocode, this is the notation. We still have a return info, and by the time we get back onto line 14, it's the same thing. We're printing whatever return linear search is returning. So that part has not changed. Let me just kind of move the columns a little bit here. We still have the three things. We have A, K, and also I as things that belong to the subroutine. But A this time is passed by reference. The question now is, how do we pass an array by reference? That's the question. And it's a very interesting question, because if you want to stick to whatever C and C++, what it does, it's really A is a reference to A bracket 0. In other words, the array, the subroutine only knows where A begins. It doesn't know where it ends, which is very problematic. Okay, but in this class, we'll idealize the situation and say that A as a parameter knows where it is ending. So in this case, we'll say A as a parameter is also known as columns. In this case, not a single column. It's going. I have to look up the name here. D to F. K is passed by value, so it's the same way as last time. And I is a local variable, which also means that it starts with an unknown value. Now remember, once again, this is what I call an idealized situation, where the parameter can know where the array is supposed to begin and also where it ends. But in an actual C program, it does not know where it ends. Okay? All right. So now that we make that bold assumption, we can continue with the loop. So from line 14, we have to go to linear search, and that starts on line 5. Line 5 initializes I to 0, and then we move on to line 6. Line 6 has the condition to evaluate, which is the same as last time. I is less than bar A bar is true, and K is different from A bracket I is, let's find out how to evaluate this. Okay, when we want to figure out, K is different from A bracket I, we have to look up A. What is A? A is which column? It's column H, right? So A is a reference to columns D to F. Now columns D to F, if you look up, well, I cannot show it here because I cannot show that many columns, but columns D to F is an array, and within that array, the first element, which is A bracket 0, has a value of 5. Okay, if I scroll back, you can see it. See, when you look at columns, D to F, column, the first one, has a value of 5. So we have true and true here, so the end result is true. Are there any questions here? Because this can be confusing. A as a pass by reference parameter is referring to the entire array. Is that okay? The rest of the program is pretty boring because it is just about the same thing as last time, except we are not referring to a local array. We are actually referring back to an array that is outside of the context of the subroutine linear search.
But you're only looking at a specific index area.
Sorry?
So you're looking back at the whole array, then you're only looking at when I is equal to 0 or 1, right? You're looking at one spot.
Only looking at one spot at a time.
Okay.
And I as a local variable is still controlling which spot you're looking at. But we are no longer looking at an array that is created inside linear search. It is an array that is created before linear search is called. So line 6 goes here. We still have the condition being true. And we go back to line 7. This is now 3. And then the condition I is less than bar a bar becomes false. On line 6, we get out. So the rest of the program is pretty much the same as last time. So line 9 has to return a false here. And then we go to line 10. Line 10 is deallocating all the columns, and then continue execution on line 14. Deallocate this. Now we're back onto line 14. Line 14 is just printing false. So we print the value false. Oops, wrong row. Print false. And then we go to line 15. The rest of the program is pretty much the same at this point. So we have line 15. We have to go back to post. And then we deallocate these columns. So the program is pretty much the same as before, except we do not have to create another array as a parameter. Yep.
That looks much more simpler.
Well, but it does pose one danger. Okay, what if whoever is writing the linear search algorithm accidentally put an assignment statement and change array A in the subroutine linear search? It will actually go ahead and change the actual array. Does it? Do you understand what I'm saying? Okay, when you pass by value, there's no way the subroutine can accidentally change the content of whatever is used to specify the parameter. Is that making any sense?
Yeah.
Because all you have access to is a copy of the original. Now, when I'm passing the reference to the original item, it means the subroutine now has access to the original item. And if it makes a mistake, I can accidentally use an assignment statement inside linear search. It can actually change the array in this case. Okay, so passing by reference has this one minor problem of giving the subroutine too much sometimes. And the subroutine can mess up and change something that it is not supposed to. Is that making any sense? Is that okay? So how do we avoid that problem? Just write the program more carefully. Well, okay, this is outside of the a little bit outside of the context of this program, of this class. But I will just kind of show you the concept that you will see in C++ programming. The answer is to go here and then change this by ref to constant by ref. Okay. In other words, and it doesn't change the trace whatsoever. The trace of this program will be identical to what we have done so far. What is the difference? What do you think is the difference here? Well, the const means this you are not supposed to change anything in array A. So if I make a mistake and say A bracket I gets whatever value, the compiler will then complain and say, hey, you just said that you're not going to change anything in array A, and here you are changing something. And it is up to the compiler to enforce that rule and stop compiling and just say that, hey, you're not supposed to do this.
So it almost makes by ref similar to by value, except with the benefit of it not
Exactly. Yep. So that's how you're supposed to write programs in C++ is to use the const word whenever it is applicable. Use it so that the compiler can make sure that you're not changing something that you're not supposed to.
So it makes it read only then.
Exactly. Yeah. Const is basically read only.
Okay.
Yep.
Well, it seems kind of
Sorry.
the constant by ref, meaning that none of the assignment statements within the subroutine will work. But if you put, like, there's no point in writing assignment statements. It seems kind of redundant.
It is not redundant because the how should I put it? It makes sure that whoever is implementing the subroutine cannot accidentally change an array that is passed by reference. Now in this case, yes, it is very simple and it seems kind of obvious that we should not be changing the array, but there are other cases where it is kind of not so simple. And also remember, the subroutine linear search, in this case it's too simple to invoke other subroutines, but you can kind of imagine that a subroutine can call other subroutine can call other subroutines. You see what I'm saying? So even though you as a subroutine are not making any changes to a parameter that is passed to you, as you pass it along by reference to somebody else, you also have to make sure that they do not make any changes to that array. So the word const is supposed to kind of daisy chain all the way down, so that if I'm linear search and someone is passing a, in this case, using const, which means read only to me, when I invoke other subroutines, the compiler will also make sure that the other subroutines also have that particular parameter enforced by read only. So this is all done by the compiler to make sure that you are writing the program playing by the rules. But the mechanism of how this is done is identical to last time. In other words, the trace of this program is the same as this, because the mechanism has not changed. It is just that the compiler is going to enforce const, or if you want, it's the same as read only. It's the same thing as giving me a little slip of paper with a call number of not a book in this case. This is a call number of an entire shelf with a lot of books, with a little note under the call number and say, do not vandalize. Okay, do not make any changes. Do not scribble on any one of those books, and I have to play by the rules. Is that making any sense? Okay. All right. Any other questions about how arrays and subroutines can intermix? How about returning an entire array? Not possible in C, not the way I'm describing it. Okay. Are there any questions about arrays or subroutines and how those two can mix up, can kind of work together? No questions? Too tired. All right. If there are no questions about this, we'll start the next topic in Moodle. So I'm going back to Moodle first. The next topic has to do with records and user-defined types. So this is our notes here. You should start to read it whenever you have time. But instead of reading it, I'm going to start with an example. Okay, and once I use the example, you guys will understand why records are useful. Okay. When was the last time you have to fill in a form? Online or otherwise, doesn't matter. Okay, months ago. Let's just say that you had to fill in a physical form. Most of us still remember what it is like to fill in a physical form. Okay, so I'm going to draw a picture here on the whiteboard. The recorder will still record what I'm drawing, so that's fine. Okay, so a physical form has probably multiple fields, right? Okay, so if you're applying for ARC, or if you're doing any type of registration, probably has a field for your name, right? And in your name, it probably has something under the line that says first, middle initial, and last, right? Some of the forms may ask you for your telephone number. Okay? And I know these days, it has like at least 5 or 6 rows just for your phone numbers, right? But let's just say that there's one. Within the phone number, we have the area code, the local area code, and then a dash. Okay. Well, let's just say that we have a student number here too. Student number, like that. Okay. So this is a very simple form. Okay. And you might think that this is a form that you have to fill in with whatever student service that you want to sign up on campus. Yep.
Attendance log.
Sorry?
Attendance.
Attendance. Very good. Thanks for the reminder.
That's a form we need to fill out.
I can't program my phone to remind me because I turned off the ringer. I can use Moodle. I think. Yeah, you can just pop up a big screen here and say, take roll. Pass the roll sheet.
Recording script to launch a reminder.
Yep. All right. So if you look at this form here and say, does it make sense? Okay, it's fairly okay as a form like this. And if you have a form like this and somebody else has a form like this, you run into each other and then you both drop the form. Is it difficult for you to pick up your form? Let's say it's already filled in completely. It's filled in. Okay, it's fairly easy to pick up your own form. Is there a possibility of mixing it up? Like pretty hard, right? Okay. Now think about it like this. Okay. So instead of having a form like this, I'm chopping this form into little slips of paper. One little slip of paper for your first name, one for your initial, one for your last name, one for the area code of your phone number, one for this part, one for this part, and then your student number. So I'm breaking this form into 1, 2, 3, 4, 5, 6, and 7 little slips of paper. Okay? And once again, you run into another student, and you both drop your big pile of little slips of paper. This time, is it easier to kind of get mixed up when you pick up all the little slips of paper? It gets a little bit easier, okay, to get things all mixed up. And that's the reason why we have records. Because up to this point, what we have only talked about are arrays and individual variables. These are individual variables. We have 7 individual variables here to represent one single logical entity. Okay? So we want to group things that are logically related into a single logical container. Now we do have arrays, but arrays cannot serve this purpose for a very important reason. What is one of the requirements of arrays? All the items within an array must be the same type. Okay? They all have to be like items. If you have a box of coffee mugs, then you can only have coffee mugs. You cannot mix in like wine glasses with coffee mugs. Okay? In this case, do we have the same type with all these different fields? Some are numbers, some are text, and one is a character only and stuff like that. And that means an array cannot help us organize these things. So what we need is a record. Okay? This is exactly what a record is. So I'll go through a very simple program before the end of this class. And make sure I save this one first. Okay. Because I don't want to use global variables, so we'll just use main in this case. Oh, I cannot do that yet. I have to define the record first. So I want to define the record. Let's say it's a date. Okay. And a date has a year, which is an integer, has a month, that's an integer, has a day of month, DOM, which is also an integer, and record. We'll talk about this again on Thursday, well, not on Thursday, but next Tuesday. And I'll say local, today is a date. We'll say today dot year is 2012. Today dot month is November. Today dot DOM, date of month, is the 13th. And define sub, invoke main. All right, so we'll just take a quick look at this program. I know we are kind of running out of time, but I think we still have enough time to look at this program, not necessarily trace it, but to talk about the most important, concepts. Do you see date here? Record and end record. That's the definition of a record. When you see the local variable today is a date, that's a local variable. What is the difference? The best way I can describe it is one is defining the shape of a cookie cutter. This is a cookie cutter. Okay? It's basically saying that I'm defining a new type called date, and it has 3 components. The first component is called a year. It's an integer. The second component is a month. It's also an integer. And the last component is day of month, which is also an integer. What I'm doing here on line 7 is cutting out a cookie using the cookie cutter called date. So today is a cookie cut out by the cookie cutter called date. Are we making any sense here? Kind of. And with a cookie, you can now do other things. You can say, oh, with this particular record instance, I want to change the year part to 2012. The next one is changing the month and then also the day of month. Now, with this concept, okay, I'm just going to put one more thing here. You can also define another local variable called yesterday, which is also a date. So now I have 2 cookies. One is called today, the other one is called yesterday. They have the same shape because the cookie cutter has 3 fields, has 3 items in it. Okay? If you want to use a physical form, equivalent, this is a template of a form. You never modify this, template. You never fill it in. You just leave it in the office so you can crank out more actual forms. These 2 are actual forms that for other people to fill in. And this is the same as filling in a form. Basically, you're looking at each individual item inside the form and basically change it or overwrite it one at a time. So we'll talk about this again, next week, when we have time. But go ahead and read my notes ahead of time first. It should be helpful.
So the test is going to be, the next exam is going to be next Tuesday.
Next Thursday.
Next Thursday we're off.
We can make it next Tuesday or the Tuesday after Thanksgiving.
No one's going to remember anything after Thanksgiving.
We'll do it next Tuesday. You'll get better grades. Okay. Well, I want you guys to get better grades. Okay, so next Tuesday then. Next Tuesday is the second exam.
Next.
Then you have an easier Thanksgiving. You don't have to worry about it.